Of schema-based constraints, we're now looking at our key constraints for this diagram. So SK is a superkey of R. If for any two distinct tuples, T1 and T2, and tuples are rows in a relation state R of R, so like our attributes, we have the constraint that our T1 SK is with the T2 SK, and a superkey is basically a key identifier, and we're going to go more about this soon. So we have key constraints and unique constraints. No two distinct tuples in any state R can have the same value for SK. In the ER diagram, we do not have a superkey, only a regular key. And the ER diagram is what we done in the previous last section when we have this. Notice how we only have one key for each of these, but we can have multiple key for these entities, whereas in our current place we are only going to have one key. And the lowercase r is the state and the uppercase r is the schema. So that is what that is for. We went over that previously. Lowercase r is state, uppercase is the schema. We have a example here, and this is for our superkey SK. We have our SSN, or name and age. If we remove a specific one of these, like if we remove age, this will still be a superkey. It's still a unique identifier. Now, any superkey is not a key. We have these all in here. Age itself is not a key. It is just a value. It's not anything specific because it changes. Social security number is a key though, and it's tied to a name. So that would make this a superkey. Any key, though, is a superkey. So any superkey does not mean it's a key, but any key is going to be a superkey. So like this, look at these examples we have here. For this first one, we have capacity, building, and room number. So room number is a superkey, but it is not a key because it relies on building. Now let's look at if we remove capacity and we have building and room number. Our room number is still a superkey, and it's a key because we have our capacity gone, so it's just with these two. And we don't have anything that's not a key like capacity. Then we have some notes down here. This is a key because we need to have the building and class room number for this to be a superkey. Building is many rooms, and a room number is not a uniquely identifiable. It's based off the building. Now we're going to go to our next page where we talk more about keys, and we're going to skip constraint on nulls, entity integrity constraints, and referral, the other one, integrity constraints, and we'll come back to these later in the next video. That'll be in the playlist link below, like button. So we have more on keys, like in an ER diagram. A key is a minimal superkey. A superkey such that removal of any attribute from K results in a set of attributes that's not a superkey. So like we have our SSN here. A relation schema may have more than one key. Each of the keys is called a candidate key. So like let's look at this example right here. Our candidate keys would be license number and our engine serial number. Now for this diagram we only want one key. And by the way, car is our element, it's out front. We underline only the primary key for the relation model. So that's what we're important here. In an ER diagram, we know we can underline multiple things like our license number, engine serial number. This can only be of the top attributes though. So remember that these are the keys, it still has to be a key. And then we have an example here where we have a composite, where we have a superkey, classroom, and like we were talking about, we have building and a room number. We would underline both of these because these are the superkeys and they are the composite part. Now we're going to look at primary key and foreign key. Our ER diagram does not have a primary key, just has a key, but this does have a primary key. We designate one of the candidate keys as the primary key of the relation, so like we've just talked about here previously. The choice of primary key from candidate keys is arbitrary, and our candidate keys would be like license number or engine serial number, anything that we could choose from. It's arbitrary, meaning it doesn't matter which one we pick. However, it is better to choose a primary key with a single attribute or smaller number of attributes, so the less that we have. The primary key attribute will be underlined. Like here, but not here, there are just two to make the notes stand out. So we only have two here, but we could have more that we can distinguish from if we wanted to. Next we have a foreign key. A foreign key is a set of attributes, FK is what we're going to call it for short, and they're in relation schema. We've talked about this previously where we have R subscript 1, and it's a foreign key of R1 that references relation to R2. So we have like R1, it's an attribute, and it's an attribute that's a key, and it's going to relate to our R2. So we have two keys basically relating to each other, two attributes. They don't have to be necessarily two keys, but two attributes relating to each other. We're not going to have to underline a foreign key, but we'll look at this in a second. We have the attributes inner FK, foreign key, have the same domains as the primary key attributes, which is the PK of R2. And this is because we want them to relate. A value of FK in a tuple T of the current state R1, and then big R1, either occurs as a value of PK for some tuple T2 in the current state R2, uppercase R2, or it is null. So we have our current state where our T1 references or refers to our T2. What this means is that we have some T1, right, our tuple, and then we have our foreign key, and then this is equal to our second tuple, and this is equal, or this is part of the primary key, and they refer to each other. Now, they can refer to its own relation, and we're going to see that in an example in the future. It's not going to be one in this video, but we're going to have one where we come up soon and we talk about the actual referential integrity constraints, where we demonstrate that in this example. But back down to our foreign key, it can refer to its own relation, and if we have an example here, so we have like a student ID number, a name, and a major, and then we have the department. And in this department, we have the number, the name, and like so on. The important part is the major. The major is a foreign key and it relates to the department name. Because if the major doesn't exist, that means we don't have something for the department name. So if there is no department name, like let's say there was no CSC, then this major would not exist. So the foreign key must point to like the primary key of this department. We again don't want to underline foreign keys unless it also serves as a primary key. So if we had like social security number related to a different attribute key, then we would underline that if it was a primary key, but the major is not primary key, the student ID would be. And so we have all these examples, and that's how we would look at our foreign key. Next, we are going to look and come back up here to our schema-based constraints still, and we're going to look at constraints on nulls, entity integrity constraints, that'll be one video, and then we are going to look at referential integrity constraints.